All right. I'm sure there'll be maybe a few more trickling in, but it's great to see a lot of attendees on today's webinar. Thank you all for joining. My name is Brandon Waters. I'm the VP of Sales and Marketing with CGIS. We love to put these on. We try to do them at least monthly. We've been doing it now for about 3 or 4 years, and it's great to see the attendance continues to go up. This one in particular, we have a number of returning guests as well as quite a few new ones. So it's fantastic to see that. This one at CGIS, we really try to meet our vision of a world without valve problems. Valves have become fairly commoditized over the last number of years. We still see that as an asset that when applied properly into the right application, the right valve can really create a lot of efficiencies in the system, a lot of trouble-free long life. In order for us to be able to select those right valves, we need to partner with the world's best valve manufacturers. And today I'm joined by one of those great manufacturers, Adams. And they'll be taking us through optimizing water and wastewater systems with combined function check and isolation valves. So this is a very specialized product. So again, it's great to see so many people on, but a product that Adams has done for a number of years very successfully to solve some of those problems that we see with using individual check valves and isolation valves and systems. Joining me today, we've got Chad Ferris, who's the Regional Sales Manager for Adams covering Canada. Chad's been in the industry in design and manufacturing for 20 years and has been with Adams for 6 years as a Sales Regional Manager. Also online in Houston, Texas is Paul Kanzig. Paul's a National Sales Manager for Adams. Again, been selling and helping customers with triple offset butterfly valves and check valves for over 25 years. So a lot of experience in the room. We'll just quickly go a couple things and I'll pass it over to you. So next slide there, Chad. So just again, one of the things that makes these webinars really successful is the feedback and the questions throughout. So Paul and I will be monitoring the Q&A. The bottom of your screen for Zoom, you'll see a Q&A button. Click on that and type away any questions as you go. If it's relevant to the topic at hand, we might interrupt Chad and ask a question right away. If not, we'll definitely get to it at the end of the show. So please ask those questions. And then at the end, Sam will be sending out a recap of the session. And definitely, if there's any other questions that you'd like to follow up on, please feel free to do so at that time. So with that, I will stop talking and hand it over to the expert here. Chad, take it away.
Thanks, Brad. So thank you, everyone, for your time. We'll run through this. Hopefully, some of this is maybe information you already know, but there should be some interesting topics in here. So we all come away with this with a better understanding of Adams' approach to check valves in water. Adams is a German-based company, been in business for over 60 years now, still family-owned and operated. Back in 1960, Adams invented the triple offset metal-seated butterfly valve, which we'll touch on a little later in the presentation. We do have an extensive network of sales reps and distributors, premier companies like CGIS that cover Canada for us. As I mentioned, our home office is in Herne, Germany. So if you were ever to go over there for witness testing, you'd fly to Frankfurt and then hop on a train for about an hour and a half. We've got over 1 million square feet under roof there in Herne. We do have another facility in Switzerland, right there at the base of the Swiss Alps. Their primary focus is going to be on large diameter valves that are going to be in the hydroelectric industry, penstock, fixed cones, etc. And then, our little shop in Houston, Texas, where we keep inventory on hand and obviously house the sales office and have service capability, whether it's sending a technician to the field or having end users send product to our shop. We're almost always in some sort of a turnaround for clients. So wonderful capabilities right here in North America. The Adams product range, as you can see, is wide ranging in size, temperature, pressure class. As you can imagine, being a German-owned company in business, as long as we have been, we meet or exceed industry standards and are comfortable with several types of materials. Standard materials for us is going to be carbon steel body with stainless steel trim, but as you can see, we have several installations that utilize other types of materials. Actuation is never a problem for us. We're comfortable with whatever the client needs are. And finally, today, our focus is on check valves in liquids. So I've got that highlighted here. All of our check valves incorporate some form of a dampening system, and others also include control capabilities. Oh, skipped over there. So we have the most basic question, right? Why use a check valve? And it's the simple answer is a check valve is going to allow flow in one direction and keep it from flowing in the other direction. What Adams focuses on is smooth operation of the check valve in opening and in closing. And unlike gases, which are compressible, obviously water is not. So we place a very high emphasis on eliminating water hammer, which is why all of our check valves have some form of damping system, which is have different setups for adjustability and timing. We'll see just a standard check valve. You obviously have the pressure will go up as the flow increases and then become steady. The closing of a standard check valve is where our damping system becomes critical. We want to avoid that shock to the system that could damage the valve. Obviously, a very expensive pump. The piping, we've seen field applications where the piping has jumped off of the rails completely. So we want to protect all the equipment. We don't want slamming. We obviously do not want water hammer. So just a basic layout of our dampening system will include a spring hydraulic piston with, you can see those two red valves on the depiction there. Those valves are field adjustable, and that's what gives you your multi-rate closing of the disc, so that when a customer experiences a trip, the closure is smooth. It doesn't slam, it doesn't damage the disc, and we don't get water hammer. The further here you can see, because of Adams' high eccentricity of the disc, this also aids us in smooth operation of the valve, keeps it from fluttering or jumping, and also brings it gently into the seat. I believe this is once the pump is activated. You'll see the hydraulic system controls the opening and closing. But the valve is a free acting check valve at this point. It is just smooth operation. We have just a simple depiction of the valve, again, closing. In real time, this would happen very, very quickly. But the controllability of the closing keeps the valve or system from getting damaged. So main lines for us all those letters are German. So if you speak German, that would all mean something to you, but our RZN, our GBZ, and RZI are gonna be our check valves for liquids, the ones on the bottom there for air and so forth, so. Wanted to touch on the importance of the triple offset incline conical seat design. You can see here, when Adams invented this design, having the first and second offset being the shaft has been moved vertically and then horizontally from the center of the valve body. And that gives this disc a full camming action. The third offset has to do with the geometry of the seat and the disc itself. So that if you were to draw lines out to the right from that those angles, the point of that cone is an inclined cone. It wouldn't be centered in the valve body. And this allows the disc to come into the seat with no friction, no rubbing. It just sits down into the seat. And this is something that set Adams apart decades ago and allows us to provide the client with longer lasting valves that give them repeatable tight shutoff, zero leakage shutoff. And then the seal ring, 20, 30 years down the road can also be easily field replaceable with this design.
One other advantage, if I could add,
Sure.
is versus a standard swing check where your seat is being perfectly vertical, ours being offset allows the disc to easily set in. And so that helps before backflow begins to push it back. We're closed. Gravity can pull it down and into that seat, and it doesn't require that backflow to push it into the actual seat. So that is the other advantage of having the offset conical design in our check valve.
Just real quick, one question that came in on the previous slide was, are these valves piggable for pipeline applications?
No, they're
No, unfortunately not.
Okay.
So here we've got just a couple of pictures of our RZN and RZI multi-rate adjustable dampening valves, suitable for multiple water applications. The smaller valves that are going to be in raw or finished water will have an NSF 61 coating on wetted parts. We're currently in the process of getting these valves certified so that the entire valve is NSF 61 certified. And then for marine applications, we offer them with a rubber lining as well. You can start to see the damping systems on those valves, the dash pot and so forth. So we covered the triple offset design. Paul touched on the incline conical sealing system. We want to chat a bit about the adjustable damping system on all of our check valves. I think there's, so there we got so you have the flow control valves on the damping cylinder so that the client can adjust the speed at which the valve closes. And this is important on setting up the system so that we don't, you can see on this chart here that you have a first, maybe so the spring cylinder will kick in on pump trip, and then the second and third stage are controlled by the adjustable needle valves that have a hydraulic dash pot. In many cases, we will use food grade hydraulic oil if these are going to be in finished water systems. So when the pump trips, the valve wants to close. We designed the valves with internals as light as possible, for lack of a better term. It's very sensitive so that it will close quickly, but the first stage will allow the valve to close the majority of the way, and the hydraulic first stage, second stage hydraulic will kick in, slow the valve so that the final few degrees of closing are, although quick, they're not violent. So just facts and figures for the RZN, the nominal pipe sizes, temperature range, and pressure classes that these valves are manufactured in. This is a real workhorse for us, very popular all over the world. City of Regina just purchased some here, so. RZI, similar to the RZN, but as you can see, larger pipe sizes, which requires some extra design work for us on the damping system. We have, and full disclosure, these valves are adjustable with a lever and weight. Although I've never sold one with it, let me back up. You'll see these check valves do have the shaft continuing out the other side of the disc on the opposite side of the damping system, where you could include a lever and weight if you wanted to. I've yet to have a customer ask for one because they work great without them. But let me get into more detail about the RZI multi-rate adjustable system. Because of the size and weight of the disc, we have some similarities, but a few extra bells and whistles, so to speak. You can see here, you still have your adjustable valves to get your multi-stage closure of the disc, but we incorporate a slide arm that allows the designer or end user to control at what point this begins. You can slide it forward, backward. It's fully adjustable so that you have different controllability than you do with the RZN. With the RZI, you would have sort of a standard, I guess you would call this sort of factory setting of the closure. And with if you need to utilize the slide arm, you have further adjustability, which is necessary with if it's a 60-inch valve. That's a lot of weight on that disc. So in addition to the multi-stage adjustable needle valves and the hydraulic cylinder, you can further adjust using this slide component. And now we'll get into, I guess it would be kind of mine and Paul's favorites. Our check valves that also offer throttling and shutoff capability all in one valve. So this would be our type GBZ and type AZI. You can see these valves are similar on the inside with the incline design and seat, the triple offset eccentricity of the disc, but the magic happens outside of the valve body. So the AZI and GBZ both work as check valves, free acting check valves, but it gives the user the ability to control the valve as well. We've regularly put position indicators on these valves so that the user knows exactly where the disc is at all times. They still come with the adjustable multi-rate damping system, but they also offer the client the ability to control this disc on pump startup and closure, so that they can use this valve for isolation and then throttling. And once the pump is running, it's a free acting check valve. And we accomplish that by what we call a free travel coupling. It's a clutch, if you will. And when the free travel coupling is disengaged, the valve will act as a free acting check valve. but the operator can then engage the free travel coupling and control the position of the disc.
One of the questions that came in right now, and I think it's a good one in general for the check valve as well as the MAK triple offset, is how well do these check valves seat with debris laden fluids? Do you want to maybe quickly?
So
What's that?
we always want to know when it comes to particulates, we would like to get an idea of three things, and that's going to be the size of the particulate, the percentage of the particulate, and then the velocity of the particulate. These things will affect our seal ring, which is standard seal ring is laminated layers of titanium reinforced stainless steel and graphite. So we have had many applications where a valve will close on a twig or something like that and be just fine. But if it's going to be a very rough application, we'll make some adjustments with different types of sealing on the bearings, adjustments even on the packing and the seal ring design. All those things can be custom designed. We do have limits. If it's just a pipe sucking sand off the bottom, we're probably going to pass. We'll
And that's actually brings up a good point. These valves are not a cookie cutter design. These are custom made valves. They are made to the standards as Chad mentioned, to API, ASME standards, but because a lot of them are fabricated, when the larger you get, the more they are going to be a fabricated instead of a cast valve. And so we can do some unique things with that. And so that's why this would definitely be something that we'll be working with you. CGIS will work with you to understand the application and your requirements, everything from your flowing media to your pump sizing, so that we can get the right disc. As Chad mentioned, we can customize the disc so it's more reactive to your system. We can do special face-to-face dimensions on this and special flanges. So this is not going to be I need a 12-inch off the shelf. That's not going to be this product. This is definitely a customized for your application valve.
But just to follow up to that, I know in your MAK triple offset design that the seat ring has been moved out of the disc into the body to protect it. Is the same technology used in the AZI GBZ, or is it in the body still?
So on our check valves, we incorporate the seal ring in the disc.
Yeah.
Okay. And this works for us because these discs never achieve full 90 degrees.
Right. Okay. Gotcha.
Our isolation valves, we're more concerned about the sealing being on the leading edge of the disc. For example, we sell isolation valves into the steam industry by the thousands. And those valves live the majority of their life fully open. So, and they're expected to last for 20 years. So it makes sense for us to then remove the seal ring from the disc and have it recessed into the body. Not so much in the case of check valves. So
just going back to that question, I know when the triple offset butterfly design with that seat protected, we normally say we're good to sort of 4 or 5% solids without worry compared to some of the other triple offset designs where the seat in the body is exposed and definitely debris and particularly can have an effect on the sealability of the valve, whereas you guys or Adams were fairly confident with higher percentage of solids. And again, being metal to metal, true zero leakage isolation, we can maintain that fairly significantly. So
I agree. Yeah, we're comfortable with that. You guys up here see plenty of applications where we're successful in the 4 to 5% range and still get long-lasting, repeatable results.
Before you go any further, I got one more question that popped in, and then we'll get moving. The combined function check is available for natural gas, sour or sweet applications. I assume yes. Right now we're sort of focusing on the liquid ones, but if you looked at that that decision tree, there
Yeah,
was a
the
whole
flip
bottom.
sheet. Yeah, there's we have a whole nother line for those, and yes, we offer these same functionality in gases, so.
Design will be slightly different, but yes, it's the same concept.
Right, in refineries where they have a main air blower or control air blower, our valves are very popular because they can track the position of that disc, they can control it on startup and shut down. But if there's a system trip, it closes very quickly, but smoothly, so.
Right.
And it also, as Paul mentioned, having that incline conical design, sometimes, I don't know who all we've got on the webinar here, but a standard swing check valve that's 25 years old that gets some wear on it may close most of the way, but not all the way. Ours close all the way. Or they'll hit the seat and bounce off and be off 6, 7, 8 degrees. We are not interested in that type of valve performance here at Adams. So.
Thanks.
Point of note with the combined function valve is it eliminates the need for a check and an isolation valve. So you're going to, when you're designing a system, you can lower your weight. Space requirements are obviously at a premium in a lot of underground or in-ground vaults. And you're still going to, there's cost savings and pressure drop benefits as well. We generally see 1 to 2 PSI pressure drop across our discs and our check valves. So
This one thing I think to mention too is, best practice for check valves is to have a free run before and after the valve, the check valve before an isolation valve or an elbow or anything like that. And so space really becomes a concern, especially with the larger valves, having to get that 5 or 6 pipe diameters in front and after the check valve, whereas you can combine it, that eliminates that one consideration.
Exactly. So if we're new systems being designed or retrofitting an old system where we want all of the weight and space savings along with combined function, this is an excellent option for an operator. We have so there's the GBZ size range, temperature range, pressure classes. You can see there it still has the multi-rate adjustable dashpot. You can't quite see the needle valves, but they're there. And then obviously the gearbox that allows the operator, if they need to go up and open or close this valve. And then you can add actuation to this. Many times it's electric, but I think we have there you go. This one includes a gear and motor combination. Again, with the AZI is similar with the larger sizes there. You'll see like the RZN, it has an extra spring on the bottom, and then that goes back to just the sheer mass of the disc. So our combined function check valves are pretty unique to the industry in how they operate, how well they operate, how long they operate, and all the options it gives the client, the functionality on startup, shutdown, allowing the free travel coupling to disengage and have a check valve running smoothly that's not going to flutter or slam. And these valves being adjustable offer the client the option down the road should process conditions change. If the manifold changes, any number of reasons, this valve can be adjusted in 10 years. So a wonderful thing to be able to at least put in front of a client that's looking for something that's going to be long lasting and reliable and flexible. As Paul had mentioned, many of these are made from scratch. So the internals will be custom to the design. The face-to-face can be custom to the design. The damping system can be customized. The gear and motor combination can be customized. We can tailor the solution. CGIS is one of the premier distributors in the world when it comes to working with clients and getting them exactly what it is that they need.
Question that came up talking about that is valves. Is this valve suitable for variable speed drive or variable speed pump operation? And,
That question comes up a lot, you know, and that's the benefit of a variable speed pump is that, of course, you can slow it down more. So in a variable speed pump, I've seen actually less issues with water hammer, I would say, because as they can tone it down, but it will work. This check valve doesn't matter the speed of the pump, because what we're dampening is your closure. So it would still be good for that in case that you do have a pump, it trips instead of being a controlled shutdown of that pump, it trips and you have that backflow. So you would still be able to see the benefit of having the dampening system on it. One of the benefits, I think, is this is on startup. And that's where I guess maybe the variable speed pumps are maybe a little bit better on startup. If you have a standard pump that's not variable, sometimes you start up that pump and you get a very big surge of flow coming in. And of course, that is just startup and it will slam that disc wide open, but there's not enough flow to maintain the disc being in the open position, and it will slam the disc back closed. And you get that happening, that cycling as you start up. You get that rapid opening and closing for quite a bit of time, and that can damage the internals of a check valve. With this combined function, as Chad mentioned, we can throttle it open, especially with like an electric actuator as is shown here. You can have it programmed to open to 10 or 20 degrees only, and it will hold that disc edge just like this picture. It will hold that disc in that position. Then when you are ready for full operation, normal operation, you go to the midpoint on the travel of the gear, and that will put that disc into a standard check mode. So it will be no longer being held by the actuator. It is in a free check mode. So you have a standard check valve. And then when you're ready to shut down, it can go the opposite way and force it closed. If you want to force it closed against flow, it can be sized that way. We typically do not recommend that it be sized large enough to close on its own against flow. We would rather have it operate as a check valve and then just have the safety function to close as an isolation valve and to hold it closed. So it's very unique. We do have some additional slides to kind of show how that free travel coupling works, because it is it's a very unique, as Chad said, a very unique feature for Adams to be able to have that isolation valve, which you can claim it as an isolation valve, and you can still claim this as a check valve because it will be disengaged completely from the actuator when it is in the check mode. So I hope that answered the variable speed pump question. And if it didn't, we can further clarify it. So
in essence, really on startup, then this valve can be used as to create the back pressure you need to prime your pump or ensure that you don't get out of control downstream.
Correct. And this AZI specifically, there are several applications or installations across Canada. City of London uses this. Cardinal Power uses these. Vancouver Island, the Calpine there uses these. So they are installed throughout Canada in service currently.
Thanks. All right. Back to you guys.
I believe. And then this goes. So that was the end of this part of the presentation. I think Paul did over.
Yeah, I think if you keep going, I think there's one more slide. This next slides or
Yeah. Yeah. So this kind of show you a little bit better how that free coupling or free travel coupling works, as we call it. It's a little harder to see here, but the green section is going to be the part that is attached to the actuator, and the yellow is the what's actually on the disc. So if you want to play that video, Chad, as you can see, we have it here in the locked isolated position. Maybe our video isn't going to play in Zoom.
Yeah, not sure why that's happening. I'll find another slide deck. Bear with me for a sec.
So maybe the video didn't come over across as well. But you can see, actually, if you go back one slide there, you can kind of see in this mode, this would be the valve throttling with the gear. Go back one more. You can kind of see where the green and the yellow, how they're engaging. Yeah, you can kind of see that, and go back one more slide. Yeah.
Here, let me try my computer 1 sec. I'm just gonna switch the screen.
The animation helps a lot more, so bear with us.
Yeah.
That's okay. We have another slide.
All right, let's see if this works. Can you guys see my screen?
Yes.
Yeah, okay.
There we go. And you can see even this explanation down there at the bottom too, but there we go. We can see it a little bit better now. As you can see, and if you start that video, go ahead and start that video again. So we're in normal check mode. And then we are actually, I put that backwards. The yellow portion is our actuator. The green portion is my check valve. So you can see where that we turn the yellow portion of that shaft, and it's turning to then lock that disc closed to hold it closed. Okay, you want to move to the next slide. And now if to what
Braden.
sorry, Braden was saying, we can adjust and not open the valve until we're ready, until we have that pressure equalized across that disc. We can keep it locked in that closed position, and then as we see, remove the yellow, turn the yellow shaft so that the check valve then operates as a check valve. Okay. And the next one. So here, once again, we're just going into plain check valve mode. So allowing it to act as a check valve. And then the last slide is where we're just throttling it with the gear, and we are forcing it now into a certain position so that the disc throttles the flow. So it is a unique design, and something that, once again, if you have the application, we definitely want to come and talk to you in person to show you our samples and to get your application so we can customize it for what you need.
Great. Thank you, gentlemen. Maybe we'll jump to some questions. First, I guess, where do you guys, what specific applications in water wastewater do you see these being used most?
Well, it depends on the applications. I guess what we see it a lot more is multi pumps. We're going into a header system. If you have more than one pump and you're going into a header system and you want to isolate one, so one comes off a line. Well, if you're in a header system, all that flow is going to come back to the one you just turned off very quickly. And so we see that a lot in those systems, especially these combined function. So you can dampen that flow, or that speed of that disc, and that water hammer that can affect your whole piping system. and then you can have the valve be the isolation for that pump afterwards. So that is one of the main applications we really see this in, is when you have multiple pumps in one system. Another application that we see a lot of these go into are when you're pumping up over a long distance, over mountains. If you're pumping vertically, you don't have, when you turn off that one pump, instead of having multiple pumps, if you have just one pump and you're pumping for the most part horizontally, it's going to be an okay when you turn it off. You're not going to get a rush of backflow. But if you're pumping uphill more vertically than horizontal, and you shut down that pump, you're going to have a very large head of water rushing back towards that pump. And if it's not dampened appropriately, you're going to get that large water hammer and slamming effect.
Right, perfect. And that just sort of leads to the next question here that popped up. Can these be installed horizontally or vertically? And I guess the answer is yes.
Well, but for applications, you're going to want the stem of our valve is going to be horizontal. You're never going to put the stem vertically, but yes, for on flow, it can be either direction. But you got to make sure the stem is put in appropriately.
Okay, awesome. Thanks.
Yeah.
All right. Are they is the damping system set at the factory, or is it something that you recommend on-site service? Along with it?
Both. So we'll set sort of factory settings at the factory. The valve will be manufactured in Germany, shipped to our shop in Houston, where we can then add the hydraulic fluid and bleed the system and have it set and tested. But we do highly recommend on-site commissioning, because as many people on this call probably know from experience, there's what the flow is supposed to be and what the flow is. So having an Adams technician on site just to fine tune the valve is very highly recommended.
Okay. And talking about sizing, are these typically sized to the application?
Yes. We will always want to we'll say derate the trim as much as possible for the application, because we want the valve of the disc to be very sensitive to flow, so that it doesn't perform sluggishly. So although the body and flange rating will be in accordance with the piping system, we will customize the trim.
I think that's one of the misnomers we see in the industry, is that check valves tend to be line sized and not properly sized like a control valve should be. And when that happens, typically the flow rates aren't substantial enough to keep that disc up and stable at the flows, and that's where you get into trouble with a lot of movement, a lot of fluttering in your disc, and that mechanical wear. And so properly sized check valves, something that we always recommend. Adams does as well. So that's good to hear.
That's a good point. That, I mean, I think most people on the call probably already know that, but check valves, they need a cracking pressure, basically just to open it, to start it. But everything else that maintains the position of that disc, as you said, is based on flow. And so pressure doesn't matter as much as flow on check valve applications.
Perfect. Sounds good. You mentioned you guys are doing more and more seawater. So coatings are one thing. How about duplexes, super duplexes? Are you guys starting to see that more often?
Yes.
Okay. And that's available in product offer?
Yes, we are seeing a lot of it in marine applications. We're seeing a lot of it in the Middle East, harsh environments, obviously saltwater environment. So yeah, duplex, super duplex, the coating systems, all to provide longevity of the valve. They're not cheap, so we need them to last.
Right. Right. Last question here. Standard. So I think you touched on it. And I saw some, but are combined functions, is there a standards for combined function checks or? They, like you said, sort of made to order and,
Yeah, so we'll adhere to the ASME API standards. Many times we've customized the valves to fit into an AWWA standard. As I mentioned a little while ago, we are actively involved in the process right now and should have full certification on the valves.
great, yeah.
So that not just the coating system is NSF 61 certified, but the entire valve is NSF 61 certified. So we're seeing a trend in that direction. So we want to be out in front of it, where everything around the system, the piping, the pump, everything is NSF 61.
Cool.
So
I think Braden mentioned it earlier. We do also make the MAK triple offset isolation valves. And so what Chad mentioned about NSF 61, we are also having our isolation butterfly valves certified to NSF 61 because we are seeing more of those applications in potable water increase.
Perfect. Right. Sounds good. I think that's all the questions. So again, Chad, Paul, thank you so much for your time today. For all the guests out there, thank you very much for spending the last 45 minutes with us. If you have any other questions or interested in any of this, please feel free to reach out to any of us. Sam, like I said, we'll be sending out a follow-up email. If you have any other ideas or any other topics you'd like to learn about, please send those through. Like I say, we try to do this at least every 3 or 4 weeks, have a new topic and feedback from you guys. So again, have a great safe day and we'll hope to see you soon.
thank you.
Thanks a lot.
Thank you, everyone.